Today is 1st of April 2025. Last time we talked about language model with RNN, the generative model that models probability distribution. We assume two steps of assumption to make problem simple. What we used was from previous word, we can predict next word. So the distribution, we can write distribution in this conditional probabilities format. And if we assume each of the word comes from same distribution, we can write it more simple. For today, we'll talk about RNN, and there was problem of RNN. RNN's big difference between other network is it's actually not deep in respect to input layer, but deep into the time layer. It was the problem, so researchers solved the problem, and later finally using attention mechanism to well calculate the cosine similarity, or we usually use inner product after doing the layer normalization to calculate the similarity between the two vectors. So after that, and I also talk about gradient descent, which is kind of fixed point iteration. And I thought about why can't we use interval bisection or Newton's or secant? We can't use Newton's method because it needs derivative, and interval bisection, it can only use for scalar function. But I don't know the reason, so I will go deeper later. Why bisection method for scalar function? And for LSTM, it is RNN with gate, which has cell gate and hidden gate. And we do forget input-output operations, multiplicate elementary wisely, so get a result. And so self-state update equation is the key, and it is composed with the gradient descent, which is model parameter T is determined by model parameter at T minus 1 multiplied by learning rate with plus learning rate multiplied by gradient of loss function L with respect to theta at time T. And in machine translation, it developed, and in 2014, we use neural network based model, and after that there was some problem, and there's problem of sequence order problem, and solution comes out using absolute, and just find it usually in computer vision, just find it by learning or using relative sequence order to train it. And first, my question about neural network was GLM is about function with some linear combination. And I thought how it's different with neural network. Neural network, biggest difference is neural network has several functions, which is W half 0 plus B. So maybe we can think several GLMs. And I think I should have figured out between several GLM and neural networks difference. So core thing is in GLM, we can find, if we find inverse of functions, f minus 1 y equals to this one. In neural network case, we use, as you know, forward propagation and backward propagation. And so this is the reason it is difficult to catch even weight is higher in first layer, we don't know how it impacted layer. If it is last layer, we can get directly. So, so if I speak about attention came up because RNN's time depth layer is too deep. So attention find out how to calculate it in parallelly using parallel token. So kind of they made time depth as 1. For statistical machine learning, translation was before neural network, it is based on arg max p y by x. Y is sequentially comes out. So based on x, we should find y. It was the problem, and it can be changed as based on base rule, Bayesian rule. We can change it as x bar y over py. But sequence to sequence model came out at 2014. The core thing is sequence model has as encoder and decoder. What encoder does is that can, after extract hidden state vector from RNN, we will put it to based on information. Decoder will generate target sentence. That is how encoder and decoder works. And yeah, sequence to sequence, we can use it a lot, maybe in summarization from long text to short text, maybe previous utterance to next utterance, which is dialogue, or from input text to output parse as sequence, which is parsing, or maybe we can do code generation, such as natural language to Python code. But also in sequence to sequence, problem arise, which is like multi-layer deep encoder decoder machine translation that was published in 2015. There can be bottleneck. So as a solution of bottleneck, we suggest linear interaction. The first one was linear interaction distance, so long distance and lack of parallelizability. We forbid by attention, which is computation of transformer network, using every feature of hidden input vector to decode. There's another way, which is mean pooling for RNN, but attention, what they do is weighted averaging to make one hidden vector. And we want to use it to convex combination. That is kind of goal, what they want to do. So for the attention equations, we will talk it specifically if I organize the stuff later. And the important thing in attention is there's Force-to-Max function, which is exponential function. Then even in small input vector input difference, output gets huge difference. And attention, later they use attention also in between input vectors, which is transformer block. What they do is there's cross attention and self attention, which is query and key from different sources or query and key from same sources. How they do is from token, our token from token will get key and value, and we will compute the similarity of token to make coefficient of convex combination. Query vector becomes decoder's first hidden state. And while encoding, we do fixed positional encoding or relative positional encoding. Okay. This is what we calculate from data. We will make using fully linear network, which is linear projection. We will make free and we'll multiply it. Yeah, so position encoding, relative positional encoding is ROPE. We can also discuss a layer, how we solve it. For need to ensure we don't look at the future when predicting a sequence, we use mask as a solution. Okay, for today, thank you very much.